Okay, so in this problem we're going to use Hess's law to solve for this top reaction, the delta H of this top reaction. And if we look at it, it's the thermite reaction. It's two solid aluminums going to iron 3 oxide solid. Oh, sorry, these reacting to go to 2 iron solid and aluminum 3 oxide. At 25 degrees Celsius. Okay, that becomes important if you look at these reactions below, because in the first one we have that reaction, except we have it to make it the iron a liquid at 1758 degrees Celsius, which is its melting point. We also have two other reactions that will help us figure out what we're looking for. The first one is that iron solid going to iron liquid here at 1758 degrees Celsius, 13.8 kilojoules per mole. So that gives us the phase change energy, how much it takes to go from a solid to a liquid. And then if we look at the third one here, it's for the cooling down of that solid from 1758 degrees Celsius to 25 degrees Celsius, which is what we want in the end. So Hess's law says that we can take this bigger one reaction step here that we have at the top and break it into smaller ones and add them all up as long as the reactions add together. So we have these three different reactions and we're going to add them up. So looking at this, the first thing we recognize is that A is set. We don't actually need to flip this or anything like that. We can leave that reaction exactly the way it is. B, however, I'm going to need to end up with Fe solid at 25 degrees Celsius on the right. So if we look at C, that one is actually pretty set as well, except for one thing. Right now we have one Fe solid at 25 degrees Celsius and one Fe solid at 1758. So I need 2 of the Fe solid. Okay, so what I'm going to actually have to do is take this reaction and write it as 2 Fe solid at 1758 degrees Celsius going to 2 Fe solid at 25 degrees Celsius. And that is going to take the double H and we're going to have to double it. So that is going to, the new delta H of this will equal to negative 2 times negative 45.5, so negative 91 kilojoules. Okay, so that reaction has been flipped. So now we have a new reaction C. That one is fixed. Now if we look at reaction B, we're essentially going to use this to cancel out. You can see right here that we now have this solid at 1758 fixed here. We have a liquid at 1758 fixed here on the right. This reaction, though, I need this solid, therefore, on the right side, this liquid one on the left. I'm going to have to flip it. And furthermore, it's written for 1. I need to flip it and multiply it by 2. So I'm going to end up with 2 Fe liquid at that 1758 and 2 Fe solid at 1758 degrees Celsius for a delta H now of, it's negative 2 times this. Okay, the negative because we flipped the reaction, the 2 because we multiplied it by 2. So that is going to come to negative 27.6 kilojoules. Sorry, that 7 looks like a 2. There we go. And so this reaction is gone, and this is our new reaction B. That's now fixed. Now, if we add up these, we can see pretty quickly that the 2 Fe liquid are going to cancel with these 2 Fe liquid. The 2 Fe solid at 1758 degrees here will cancel with this one, and what we're left with is exactly what we want. 2 aluminum solid, iron 3 oxide solid, and we are also left with Al2O3, so we have those so far, and 2 Fe at 25 degrees Celsius solid. There we go. So what that means is in order to find the delta H now, we're allowed to simply add up. Since we can add these 3 reactions down and get it, all we have to do is add those delta H's. So the delta H of that initial reaction is going to be equal to negative 732.5 minus now the 27.6, or really plus negative 27.6 if you want to think about it that way, and plus negative 91.0 kilojoules for a value of negative 851.1 kilojoules. So there you go. That's using Hess's law to solve for a delta H of a reaction using the summation of the other reactions.